Okay, welcome AP Stat students. Hope you guys are all staying home and staying well in these trying times. I'm going to take you through what the next step in AP Stats is, and actually it turns out the final thing that you need to learn, and that's how to do an inference / hypothesis / significance test. So you pull out your notes that you took for the homework assignment over the weekend, and also pull out your packet and open up to Inference Testing Day 3, page 115, and look for this problem right here involving a basketball player who's an 80% free throw shooter. I would pause the video while you get those two out, and then restart the video when you're ready to go. Okay, so what we're going to do here now is look at what's called an inference test. Remember with the confidence interval, we were trying to predict a range for which the population center was at, whether it was a mean or standard or proportion. Now what we're going to do with the inference test is we're going to try to test someone's claim. Someone goes out there and says, oh, I have a better aspirin than anybody else's, or Governor Ige is approved by 80% of all Hawaiian voters, or any kind of claim out there that involves numbers. People will make claims all the time, and you not sure whether to believe that or not. What we're going to do is a mathematical system to show whether we believe a particular claim. If you look at the problem that we're going to be looking at today, we have a basketball player who is claiming to be an 80% free throw shooter. He goes up to the basketball coach and says, hey, I'm a good shooter. I can make 80% of my free throw shooters. Basketball coach, always looking for good shooters, says, great. Go over here and I want you to randomly shoot 50 free throws and see what happens. So he goes over there, his manager goes over and watches, counts how many free throws he makes. Makes 32 out of 50. Comes out 64%. Obviously less than 80%. But the question is, does that mean he's an 80% free throw shooter and just had a bad day? Or is an 80% free throw shooter a little bit high recommendation that he's making? So the question is, do we believe him or not? And so what we're going to do is we're going to use this to determine whether he believes him or not. We use what's called an alpha level to help us determine that. If these results of him getting 64% free throws would occur less than 5% of the time, if he was truly an 80% free throw shooter, then we're going to say we don't believe him. But if these results would occur more than 5% of the time, meaning that getting only 64% does occur fairly often, if you're an 80% free throw shooter, then we're going to believe him and say you're right. And so this alpha level helps us make a decision one way or the other. And so this is how this works. If you take a look at your notes, we're going to look at the state section, and over here you notice we for the confidence interval was really easy. We restated the problem or question on words. For inference, hypothesis, significance testing, which all means the same thing, a little bit more complicated. Over here we have up here we have categorical data. Down here we have quantitative. Now the situation we're in right now, him making or missing free throws, that's categorical. Okay, so what we're going to do here is we're going to write what's called a null hypothesis and an alternative hypothesis. The null hypothesis always involves an equals to sign and basically is the claim. In this case, his claim is that he's an 80% free throw shooter. The alternative hypothesis is, no, he's not an 80% free throw shooter, he's less than that. So let's go back to the problem for a second and let's read through this situation. And let's do what we always do when we read these problems. We just answer those three questions. Is it categorical or quantitative? Hypothesis test or confidence interval? And what kind of stats that they give us? So if we do that for this problem, we've already determined that this is categorical in nature because either makes or miss. This is an hypothesis test because it doesn't have the word confidence interval. So this data we're going to write as p hat equals 0.64. So a reminder, we always do these three things to answer these three questions as we're reading the problem for the first time. Confidence interval or hypothesis test, categorical or quantitative, and then what is the stat and what symbol should we be using. So in this case, it's 0.64. Ugly, but you get the idea. Okay, so now what we're going to do now is we're going to come down here to the state section, and we're going to write, as we saw in the notes, the null hypothesis, the alternative hypothesis, and we're going to include that alpha level, that decision-making level, which is almost always 0.05. If it's not, it'll be given to you. So we always use 0.05 unless we're told otherwise. So if you notice here, here's the null hypothesis, HO, which is the symbol for null hypothesis, P equals 0.8. This is his claim. He makes 80% of all free throws that he shoots. And we write it in symbols and in words. The alternative hypothesis is that he makes less than 80%. He's not quite an 80% free throw shooter. And again, we write it in symbols and words. If you notice, the two symbols are P, not P hat, because we're trying to predict for all the free throws that he shoots, which is his population. We're going to use our P hat to either confirm or refute his claim. Okay, so these are the three things that we need to include in the state section: a null hypothesis in symbols and words, an alternative hypothesis in symbols and words, and the alpha level. If you take a look at your notes, that's exactly what it says here. Our null hypothesis, alternative hypothesis, each in context means in words, and we record the alpha level. We use 0.05. Okay, now we're going to go to the plan section, which thankfully is exactly the same for hypothesis testing as it was for confidence intervals. We still have our three categories: random, normal, independent. And depending on whether it's categorical or quantitative, we do these three tests. For quantitative, we look for randomness. We use central limit theorem, n is greater than or equal to 30, and we use the rule 10. But this particular situation, as we noted already, was categorical, so we're going to look for randomness. We're going to do number of successes and number of failures, and we're going to do that rule 10. So I'm going to come back here, and we're going to show how that works with this particular plan, for this particular problem for the plan. So random. This is a random sample of him shooting free throws. We asked him to go over and just randomly shoot 50 free throws, and we'll count how many you make. So that is a random collection. Check it off. Normal, he needs to have number of successes has to be at least 10. Number of failures has to be 10. And we meet that criteria because he made 32, which means if he shot 50, he would miss 18. Independent, we do the rule of 10. We take the sample size, which is 50, multiply by 10, comes out 500. And we can just be safe to assume that this basketball player who's coming up to get on the team has shot at least 500 free throws. Otherwise, he's not worth his weight. Okay, there's nobody's going to come up and come to the basketball coach and say, "I'm a good free throw shooter," without at least shooting at least 500 free throws. I'm practicing some way. So all three categories have been met. We're in the plan section. We can go on with our tests now. Okay, so now we're going to go to the do. So remember, in the do, again, looking at our notes, we have to write our formulas. Once in words, once in symbols, once in numbers. That doesn't change. Except now, instead of using the top, which is where the confidence interval is, we're going to look at the bottom of our notes for testing. So if you look here for testing, and there's words, symbols, and then we would have numbers. Okay, don't have numbers here. Okay, but for the words, and this is given to you on your AP exam, it's statistic minus parameter over standard deviation over stats. For categorical, that statistic is Z. Note that for quantitative data, which we're not going to see in this problem, but it would be T equals. So we Z, like Z-score, for categorical data, and T equals for quantitative. And there's our formula. We don't always write that little zero, which is just referring back to the null hypothesis. Remember the little zero in the null hypothesis, that H0? That's all it's saying. It says the P from the null hypothesis. So in this case, if you go back and look at your null hypothesis, oops, sorry, wrong problem. You can see that P of 0, P from the null hypothesis, there's the 0, is 0.8. So that's the number that we're referring to in this formula. I don't always write that formula. I don't always write the little 0. I'll just write the equation without these little zeros. Okay? And we're going to use this formula right here for the Z equals. That's the formula we're going to use. So if I go back to the do, you can see here, words, symbols, P hat minus P without the little 0, over square root of P times 1 minus P over N. And then I plug in the numbers. And then to get these values, we're going to do this on the calculator. So again, if you've downloaded your calculator or you have a calculator available, I'm going to show you how to do this on the calculator. So to do this kind of data on the calculator, this is how I do it. Go to Menu, Stats, Stat Tests, and we're going to complete. There's all kinds of tests up here. If you remember, number 1 and 3 and confidence intervals, we're never going to do the same thing for stat tests. We will never use number 1 and 3. They require us to know the standard deviation of the whole population, which we never know. So we have a choice between 2, 4, 5, and 6. 2 and 4 is for quantitative data. Notice the T. I referred it earlier. We would do our test statistic as T equals. That's how we know it's quantitative. For the 1 prop or 1 proportion z-test and 2 prop z-test, that is categorical. So we're going to use the 1 proportion z-test. We haven't seen a 2 proportion yet. We're going to do a 1 proportion z-test, and we're going to type in the numbers. So P0 is the P from the null hypothesis. That's what the 0 means. Go back and look at the null hypothesis, which remember it was 0.80. The number of successes was 32. The number of failures was 50. The only thing we have to watch out for is we make sure you pick the appropriate inequality symbol. In this case, we're not sure he's quite an 80% free throw shooter, so we're going to use less than, and then we hit OK. And you will see there's the 2 values that we need. There's the Z, which is negative 2.83, and there's the p-value, 0.0202339. And so I record those. If you go back to your notes, you can see it tells you what to record. For testing, we record the z-stat and the p-value. Those 2 values right there are what gets recorded in our test. So again, there's the z-stat, there's the p-value, and we're going to use in particular this p-value to help us make our decision. Okay, so let's go back to our notes now. Now we're down to the conclude. For testing, which is over here to the right, we always use alpha equals 0.05. It says when p is less than alpha, we reject the null, which is a fancy way of saying if we get a really low percentage, less than that 0.05, we get to say the null hypothesis is probably false. If p is greater than or equal to alpha, we use the word fail to reject the null. And again, this is a fancy way of saying the null hypothesis is probably true. So these are the 2 decisions. Either the null hypothesis is false or the null hypothesis is true, which makes sense. Okay? So it says when p is less than alpha, so if I go back and look at here, if you notice, my p-value is much smaller than my alpha. It's really, really small in comparison to that, which means we get to reject the null, which is a fancy way of saying the null hypothesis is probably false. Well, if that's false, then the alternative hypothesis has to be true, or probably true anyways, and which means he's probably not an 80% free throw shooter, not quite that good. If the p-value had come out greater than alpha, let's say it came out 0.08 or something, then we could have failed to reject the null, which is a fancy way of saying then the null hypothesis is probably true. But these are the words that we use. We reject the null if we want to say the null hypothesis is probably false. We fail to reject the null if we want to say the null hypothesis is probably true. And those are the words. But in this situation, we're going to reject the null, which means a null hypothesis, which is probably true, probably false, means that the null alternative hypothesis is probably true, which means he's not an 80% free throw shooter. So use this as a way to help you out with homework that has been assigned on Google Classroom. There are 2 problems on there. Both of them, first 2 are hypothesis tests. One's categorical, one's quantitative. The last problem is a review of confidence interval. Make sure you use your notes as necessary to help you fill out all the sections, and then take pictures of each of the 3 problems and upload those to Google Classroom as a way for me to check your work. Otherwise, have a great day and keep healthy, please.